A chord is a line segment which has both endpoints on the circumference of a circle. The diameter is a chord, but the diameter more specifically passes through the center of the circle. Radius is half of the diameter. When a radius meets the tangent line, it makes a 90-degree angle. A tangent line is a line that touches a circle at exactly one point on its circumference. A secant line is a line that passes through a circle and touches it at 2 points instead. If you've ever heard the expression going off on a tangent, it's when you're on point for a moment, but then you go off in a different direction. So I hope that's a good refresher for you guys. Now let's just go over a bit of a definition here. We're going to define an inscribed angle. Now I hope you remember what a central angle is, like this one right over here, where the two line segments that make the sides of the angle have endpoints on the circumference of the circle, and the vertex of the angle is at the center of the circle. However, an inscribed angle will be defined a bit differently. There's a little bit more that we should talk about before we dive into a few examples. This over here, if you recall, is the arc or the intercepted arc, meaning that the secant lines are intersecting this over here. Now, if you remember, we did earlier in the school year, in a previous unit, we did arc measure. There was arc measure and there was also arc length, but arc measure was done in degrees. The arc measure of an intercepted arc will be double the measure of the inscribed angle. The arc measure of an intercepted arc will be double the inscribed angle that passes through those same points. So if the inscribed angle is x degrees, then the intercepted arc will be 2x degrees. You should also recall from that earlier unit that the central angle also has a relationship with arc measure, where the central angle will have the same degree measure as the intercepted arc. Y degrees will be the arc measure. And remember, arc measure is not the same as arc length. Arc length is a distance. Arc measure has to do with that bend of that curve. So if that is y degrees for the central angle, the arc measure is also y degrees. Now you're going to be able to use a bunch of tricks and layering of different ideas to really solve for variables depending on where they are. Maybe they'll be on the arc, maybe they'll be the angle. Don't forget that the way you name an arc is by 2 letters if it's a minor arc, and you use 3 letters if it's a major arc. You name an angle normally with 3 points, 1, 2, 3, unless you could possibly name it by just the vertex, and of course that is determined on a case-by-case basis. So again, we have an inscribed angle. The inscribed angle is an angle formed in the interior of a circle when 2 secant lines intersect on the circle. So that would look something like this. You may not see the whole entire line. Every picture will be set up a little bit differently. And then over here we have a central angle, which we worked with in an earlier unit. Central angle is an angle formed in the interior of a circle when 2 line segments or radii meet at the center of a circle. Here we have arcs. Arcs are fractions of the circumference, or it is a piece of the circumference. Its length you can determine by using a fraction of the circumference as your formula. Its measure we can determine either by an inscribed angle or a central angle. If an inscribed angle is x degrees, the corresponding intercepted arc is a measure of 2 times x degrees, and if a central angle has a measure of y degrees, the corresponding intercepted arc has a measure of y degrees as well. So the arc measure of an intercepted arc is double the corresponding inscribed angle and equal to the corresponding central angle. So let's just dive into some examples and we will talk about them a little bit more as we do them. State if each angle is an inscribed angle. If it is, name the angle and the intercepted arc. So I'm going to do 1 and 2, and you'll do 3 and 4 on your own. Number 1, here I have the vertex of an angle at point A. Here we have 2 segments, 2 chords. Chords could be a part of a secant line, and that can get a little confusing, but you don't need to see the whole line, even though the definition describes it in terms of 2 intersecting secant lines. I could draw them in myself. Does this angle right there qualify as an inscribed angle? Yes. So I'm going to write this as a full sentence. Angle BAC is an inscribed angle. I did name it, and now I'm going to name the intercepted arc, and I'm just going to color coordinate that as well. So here's the intercepted arc, and the way you name the intercepted arc, since this one is a minor arc, we're going to use 2 points with that little curve above it. That's the end of number 1. Number 2, does this qualify as an inscribed angle? Now, the lines that intersect as the vertex, while they are secant lines, they do not intersect on the circumference of the circle. They intersect inside of the circle. Angle LKM is not an inscribed angle. And since the direction said if it is, name the angle and the intercepted arc, I already named the angle. I'm not even going to name the intercepted arc because I really don't need to. So that's number 1 and number 2, and hopefully you can use what I wrote right there to do number 3 and number 4. If it's not an inscribed angle, but you do know what kind of angle it is, you should probably go ahead and say that in your written answer. Always go one step further. You don't want to just meet the requirements, you want to exceed expectations. For this part, it says find the measure of the arc or angle indicated. So by indicated, they mean where's the question mark. So we have a question mark right over here for number 5. I'm going to do example 5 and 6, and you'll have to do example 7 and 8. The angle indicated is right here at the question mark, or angle BAC. What did we say the relationship between the arc measure and the inscribed angle was? If this angle is x, the arc measure is 2x. If this over here is 80 degrees, we're really just going to have to work backwards. And instead of a question mark, I'm just going to go ahead and change that into an x, so it's a little nicer. If that's x, that means this piece right here is 2x. So I could write down 2x equals 80. X is what I'm looking for because that is the measure of the angle indicated. So to solve for x, I need to isolate it, and to do that, I'm going to divide both sides by 2 to get x alone. X is equal to 40, so x is simply 40 degrees. Just a random extra piece of information. If I wanted what I could do is show this central angle, this right here, will also have a measure of 80 degrees because it's a central angle, and the central angles have the same measure as the intercepted arc. It didn't ask us to do that, but that was just something I wanted to point out. Now let's look at number 6. Number 6 is a little sneaky. An intercepted arc has its vertex on the circumference of a circle. So right here, W is technically an inscribed angle. If we look at it like that, really we could even pull those out and put arrows on the end to really highlight those secant lines. If this line right here is the diameter, I don't remember what color I used for diameter, maybe it was green. If that's the diameter, that means that this arc measure right here is actually the arc measure of the semicircle, and the arc measure of a semicircle is how many degrees. The full circle has an arc measure of 360 degrees, so the arc measure of a semicircle is 180 degrees. If this arc measure right here pulls back to this inscribed angle right here, then I call this x. How many degrees do you think x is? X will be half of 180 because 2x will equal 180, so x will equal 90 degrees. It's actually going to be a right angle, but that was not my indicated angle. I'm just figuring out all the components that I can gather from this picture until I can figure out the indicated measure. X was not my indicated measure. My indicated measure was right there, the highlighted yellow question mark. The arc measure between W and V, that intercepted arc. Now, before I do that, I just really want to cover as much as possible because I don't know what you're going to need for these two examples, and I want to make sure you're prepared. If that's 90, since that's 180, because that right there was the diameter telling me this was a semicircle, 90 and 42, don't forget that even though these are inscribed angles, we're also creating a triangle. How many degrees are going to be left in this corner down over there? I call this angle y. Y has to equal 48 degrees, since a triangle adds to 180 degrees. Then this arc measure is going to be double this angle. Y is 48 degrees. Then this arc measure is technically 2y. And 2y will equal how many degrees? 2y is 96 degrees, or we can call it arc WX. Measure of arc WX is 96 degrees. That fluid angle I could also call XVW, WVX, so angle WVX was 48 degrees. This X right there we could call angle VWX. I really probably shouldn't have used X there because really X was taken for that spot, so not the best judgment on my part. I apologize. Now you want to make sure you're always being really innovative. If this is 96 and that's 180, the full circle is 360, so we could figure this angle out by doing 360 minus 180, which is 180, minus 96, which is 84. So that right there is actually 84 degrees of arc measure, or measure of our WV equals 84 degrees. So I found that one by looking at the full 360 of measure around the whole circle. Or you can simply say from the very, 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 very beginning that that arc measure will be double this inscribed angle of 42 degrees. So 2 times 42 is 84. I know I took you down a whole long rabbit hole journey for this one, but like I said, I really wanted to point out a lot of crazy different things on these examples so that you can potentially use one of these tricks to help you with these two examples. Also, fun fact, this over here creates a dart, which is a type of quadrilateral that looks a little bit like an arrow in a way. So the angle measures 1, 2, 3, 4. What do you think those 4 angles add up to? Those 4 angles actually add up to 360 degrees, like any other quadrilateral.